So coming to the first application that is used in the dynamic programming algorithm, that is the matrix chain multiplication. So now let us see this application clearly. So let us first I'll give the what exactly this chain matrix multiplication will do, and after first I'll take the basic method. After that I'll use the matrix chain multiplication by using the dynamic programming. So if we have, suppose if you have a matrix A of size P by Q and a matrix B, the matrix B of size Q by R, then the product of these two matrix, that is a A and B matrix, the product of these two matrix, that is a C, is given by Cij is equal to sigma of Aik Bkj. Okay, so this is a formula for just multiplying two matrices A and B. If you multiply two matrix, that is the result is a C. So in the matrix chain multiplication, Cij is equal to sigma of Aik into Bkj, that is the row and the columns, 1 less than or equal to I less than or equal to P, 1 less than or equal to J less than or equal to R, and 1 is equal to K is equal to Q. Okay, so this is just a formula for multiplying the two matrices. So it requires a total of PQR scale matrix. So let me take a simple example. So in that example, I just give the how to multiply the matrix, the two matrices. So after that, I will take matrix chain multiplication by using the dynamic programming approach. So let us consider one example. Let's take A is equal to 13 by 5. The size of that A matrix is 13 by 5, and B is 5 by 89. C is 89 by 3, and the D is 3 by 34. Okay, I'm taking the small as well as the large numbers. So these are the four matrices. So here, different ways we can multiply the given matrix. So whatever A into B into C into D. So we have to do, we have to multiply these four matrices of size 13 by 5, 5 by 89, 89 by 3, 3 by 34. So these four matrices can be multiplied in three different ways. Okay, different ways means we can follow a different nodes. So if here there are three nodes, means we can multiply these matrix like A into B into C into D. Means first multiply AB, after that you multiply that with C, and after that you multiply the result with D. Or else you can multiply A dot B first and next C dot D. So first multiply AB, next CD, and the result of these two will multiply again. Or else you can multiply like A dot B dot C dot D. Means different ways you can multiply the given matrix of sizes, different sizes. So these can be represented in the three mode structures. So here we are having the three multiplications. The three dots means three multiplications. Means totally you are having only three nodes. So this first you can multiply like A dot B. Okay, again this dot, the result can be multiplied with C, and the final these complete result can be multiplied with D. So this is tree structure. Okay, and for this A and B first multiplied, next C and D first multiplied, and the both results will be multiplied again. This is the tree structure for this equation. And next this can be like that: A multiplied with first B and C has to multiply, and the result again multiplied with A, and the final result will be multiplied with D. So here at all trees are having only 3 nodes, means the 3 multiplication, the 3 nodes, but the structure is different. So whenever the structure is different, the result will be also different for these matrices. Okay, so here we have to multiply. The main thing is we have to be multiplied these 4 matrices, and we have to find out the best possibility, the best equation. So for for n nodes we are having suppose let me take for n nodes, the cost of the, if you take n nodes, the cost of that is 2n by n plus 1. So here there are 3 nodes. 3 nodes means 2 of 3 is total 5. Total 5 possibilities are there. So these matrix can be multiplied in 5 different ways. So in these 5 different ways, we have to select the best way. Means that gives the lowest cost to find out the matrix. The main thing, whatever we are doing that multiplications, we have to find the best matrix. So among these 5 matrices, the 5 ways, okay, we have to find out the best way. So let me take the general calculation for this. The 3 is 3. So A is 13 by 5. So let me take like A dot, B dot, C dot, D. So A is 13 by 5 and B is 5 by 89, 89 by 3 and 3 by 34. Okay, so first let me I'll show you how we'll get the different values for different ways of multiplication. So first sequence, I'll take m is equal to, let me take m is equal to A dot B, and this result will be multiplied with C. Again this result will be multiplied with D. Okay, I am going to multiply, this is the first sequence. So here A dot B means, first A dot B means 13 by 5. I am only finding the cost, not the values here. I want to find out the cost, which sequence is having contains the less cost to calculate. So 13 by 5 into 15 by 5 by 8 means just you have to take only 1 in this. So 13 by 5 by 89. Okay, dot, what is the C value? C is 89 by 3. Okay, and D is here. So this is C, and the D is 3 by 34. So now first calculate this in A dot B dot C. So what is the result? 13 by, so A dot B dot C. So 13, so here you just skip this 5, 13 by 89. So in this 2, 13 by 89 is there. 13 by 89. So from this result will be multiplied with C. That is 89 is already there. 13 by 89 into 3. Dot D is 3 by 3 into 34. So finally is 13. So from this we have to take, if you multiply these two, you will get 13, 3, 34. Okay. So whenever you have taken 13 by 89 into 3 into 34, you have to just take 13, 3, 34 sides. So now finally this will be 13 into 5 into 89. So this is a A value, plus 13 into 89 into 3 plus 13 into 3 into 34. Okay, so this is first, second and next. So the total, the 3 matrix has to be added, and the final result you will get is 10,582. So number of multiplications 1 required for this sequence. So for this sequence, the total number of multiplications required, 10,582 multiplications are required. Multiplications required means the cost of this sequence. Now let us take the another sequence. So I'm just showing here, it's a general method, not by using the dynamic approach. I'm just explaining the general method, the second sequence. So the second sequence is I'm taking M is equal to A into B into C into D. What is A? A into B means, here let me write again, A, B, C, D. So A is 13 by 5, 5 by 89, 89 by 3, I think so, 3 into 34. Is it right? 3 into 34, right. So A into B. So from this you have to take 13 by 5 by 89. 13 into 5 into 89 star. From these two, we have to take 89 into 3 into 34. Okay. So A cross B cross C cross D. So A into B first, 13 into 5 into 89. So I had to take like this, 13 into 5 into 89 plus 89 into 3 into 34, 89 into 3 into 34. So this is C into D, 89 into 3 into 34. So not this step, we have to take the plus, and plus 13 into 89 into 34. Okay, and the total sequence, here I'll get the answer as 54201. So the number of multiplications for this sequence is required 54201. And let me take the third sequence also. So in this three sequence, we have to find out which one is getting the minimum cost. M is equal to A into B into C into D. Okay. So for this, I'm just writing directly. So that is 5 into 89 into 3. And next plus 13 into 5 into, we are just multiplying the sizes. Whenever there is, suppose the equal sizes, you have to take only one. So instead of this 5 into 89 into 89 into 3, just take only one size. So both will be, when you multiply these two, this will both is having the same value, means you have to take only one. So here also same value means only one. So whenever you multiplying complete these, so you just skip this size and you have to take this rest. So 5 into, from this thing, suppose if you take these 3, 5 into 3 into 34, just skip the 89. Okay. Means from these two we have to take 5 by 3, and from this we have to take only 34, because the 3 is already, so from these two we have to take 5 into 3, and 3 is already say, so just skip this 3 and write the 34. So multiplication of B dot C dot D is 5 into 3 into 34. So like that. So here 5 into 13 into 5 into 3 plus 13 into 3 into 34. So the total matrix is that equal 2856. Okay. So for comparing all this sequence, so what is the result? So here 10,000 and here 5,000 and here this is a 2,000. So for comparing all the sequence, this A dot B dot C into D has less number of multiplications. Less number of multiplications. So for finding the number of multiplication directly, we are going to dynamic method approach to find the minimum value in different methods of multiplication. So here we are just following the normal sequence. So by using this dynamic programming approach, we can find the minimum value for the different multiplications method. We have to find the minimum value for that. So for that we have to take the problem and we have to decompose the problem into small sub problems, and we have to select the best value in that by using dynamic method approach. So that I'll explain in the next video. Thank you.